Let's walk through an example program to see how LWPython evaluates lists. First, Python evaluates the assignments in lines 1 and 2. At time 6, the current line is 3, the current tab is 0, and the variables map contains two entries, w and x, with values 1 and 2 respectively. The statement at line 3 tab 0 is y is equal to the list 3, w, and x plus 7. Line 3 is also an assignment, but the expression on the right is a list. LWPython begins by pushing the list to the expression stack. Python first evaluates the list elements. Note the similarity between list elements and function call arguments. Then Python pops and evaluates the list elements one by one, starting with 3. Next, Python pops w and evaluates it. W is 1. Next, Python evaluates x plus 7. First, the operands x and 7 are pushed to the expression stack. Python first evaluates x, then evaluates 7. Python now adds the two values at the top of the value stack. All list elements have been evaluated. LWPython can now evaluate the parent list. Python pops the top element of the value stack and reverses it. Then Python pushes this new list into the object store. Since the object store was empty, the index of the new list is 0. Python creates a reference or pointer to the list and pushes it to the value stack. Expression evaluation is now complete. Finally, Python stores the reference in variable y and exits the program. In general, if at time t the line is I, the tab is j, and the expression stack is empty, and the statement at line I tab j is x equals the Python list elements, then at time t plus 1, the line and tab are still I and j, and the list is pushed into the expression stack. Then Python pushes the list elements to the expression stack. More precisely, at time t plus 2, the line and tab stay the same, and the list elements are pushed on top of the expression stack. After LWPython has evaluated all the list elements, it performs the following actions. 1. Pop the evaluated elements from the value stack. 2. Reverse the popped elements. 3. Append the reversed list to the object store. And 4. Create a Python reference to the new list and push it to the value stack. More precisely, if at time u the expression stack contains an empty element followed by a Python list, and the value stack contains values, and the object store is OS, then at time u plus 1, the empty element and the Python list is popped from the expression stack. The value stack contains a Python reference whose value is the length of stack OS, and the object store is the result of appending the list with the reverse of the values to OS. Since stack indices start at 0, the index of the new object is the length of the object store before the object was appended. For example, if the object store contains 5 elements, then the last element is in index 4. When a new element is appended, the index of the new element is 5.